The slope of a line puts a numerical value to the direction and the amount of slant that a line has. The line that we have in this first example passes through the origin. It also passes through the point 3, 4, and 6, 8. Now, you only really need 2 points on a line. I just marked off 3 to show you that it really doesn't matter which points you mark off. The slope is defined as the vertical change per 1 unit of horizontal change. And in class, we picked out the point 3, 4, and 6, 8. To get from the point 3, 4 to the point 6, 8, there's a vertical change of 4 units. In mathematics, subtraction is used to calculate distance. For example, 8 minus 4 is equal to 4 because 8 and 4 are 4 units away from each other. The horizontal distance from 3, 4 to 6, 8 is 3 units. 6 minus 3 is 3. The overall rate of change from point to point on this line is a rise of 4 units and a run of 3. So verbally describing slope, we have vertical change over horizontal change. Vertical change can be calculated by taking your y value minus the other y value. In our problem, it was 8 and 4, so we had 8 minus 4, and then subtracting your x's in the same order. And since we calculated 8 minus 4 for the vertical change, we have to calculate 6 minus 3 for the horizontal change, giving us a ratio of 4/3. In this example, we have a line that is going downhill. Now, it passes through multiple points on our grid. We just happen to choose 1, 4, and 3, 2. Now, to get from 1, 4 to 3, 2, we have a vertical fall of 2 units and a horizontal run of 2 units. Using our formula, we have 2 minus 4 over 3 minus 1. Notice we subtract in the same direction. It's okay to subtract in either direction, just be consistent with your direction. Vertical change of down 2 is negative 2. A horizontal run of 2 units is 2 in the denominator. Negative 2 over 2 is negative 1. And so if you notice from point to point, we fall 1, run 1, over and over. Lines have a constant rate of change. Excuse me, y'all. Find the slope and y-intercept of each line. In our first example, we have the equation y equals 2x minus 6. If your equation can be written in the form y equals mx plus b, your x term contains the slope. It'll be the coefficient of x. The constant will be the y-intercept. So back up to our example, we have y equals 2x minus 6. Since we have y equals, slope is 2, y-intercept is the point 0, negative 6. And when it comes to graphing, you plot your y-intercept first. So we plot negative 6 on the y-axis. A slope of 2, which is 2 over 1, tells us we have a vertical rise of 2 units and a horizontal run of 1. If you repeat up 2 over 1, you will always find points that lie on this line. In our next example, we have y equals negative 1/4 x minus 1. This equation is in the form y equals mx plus b. M is our slope, that's negative 1/4. 0 comma b is our y-intercept, that's 0, negative 1. On the rectangular coordinate plane to your right, if we plot 0, negative 1, and then use our slope of -1/4 as directions to other points on the line. To get to another point, we can simply travel down 1 unit over 4. Down 1 over 4. If you repeat, you keep getting points that fall on this line. All you need are 2 points, but I would always recommend doing a third just to make sure that you're good. Connect those points with a line and you've got your graph. There are a couple of special cases, and you'll notice them when you look at your equation. For example, this equation only has one variable in it. Well, let's solve for it. If we add 3 to both sides, we get y equals 3. That can be written in y equals mx plus b form. It's called slope-intercept form. We don't have an x term, so we can use 0x for that. We move our 3 down, that's our constant. And so our slope is 0, and our y-intercept is 3. When you have a slope of 0, you have no vertical change. Think about a fraction with 0 in the top. For example, 0 divided by 5. That's equal to 0. Our numerator is the vertical change, and our denominator is the horizontal change. So with a slope of 0, your line just doesn't move up or down. It's just strictly a sideways motion. And we get a horizontal line that cuts through the y-axis at 0, 3. On the other hand, if your equation only contains the variable x, go ahead and isolate it, subtract 3 on both sides, we get x equals -3. Now, we're not able to write that in terms of y equals mx plus b or slope-intercept form because there's no y variable to isolate. That's okay. Think of it this way. The equation is only happy when x equals -3. So if you come over to the grid and pick out 2 or 3 or more points, as long as the x coordinate is -3, that equation's satisfied. Those will be points that all line up vertically. For this particular line, there's no y-intercept and there's an undefined slope. Now, if we go back to the verbal description of slope as vertical change over horizontal change, we have a lot of vertical change, but we don't have any horizontal change, and that would mean our denominator is 0, vertical over horizontal. Horizontal being 0 puts a 0 in the denominator, and so if you take a fraction like 5 divided by 0, that's undefined. So vertical lines have undefined slope. As long as you do have an x and a y, you will have a line that has a slant to it. Y only is horizontal, x only is vertical. But if you've got both x and y, your line will always contain a slant because it'll have a non-zero slope. Let's investigate further. This equation, 3x plus 4y equals 4, is not in slope-intercept form yet. That's down here in the black ink. But we can get it there. If we subtract 3 x's on both sides, that will leave 4y. The 4 and the minus 3x are not like terms, so we can't combine them. I'm going to actually write the x term first, -3x, and then I'm going to move the 4 to the end. So at this stage, we have 4y equals -3x plus 4. To get y totally by itself, divide all your terms by 4. 4 over 4 is 1, so we have y equals, if your fraction doesn't reduce, don't force it. That's -3/4 x, 4 over 4 is 1. Now we have it in slope-intercept form, specifically a slope of -3/4 and a y-intercept at 0, 1. Let's plot. Your y-intercept is at 0, 1, and your slope of -3/4 says we're going to fall 3, run 4. If you do that over and over, you will always find a point on this line. Connect your points with the line, and you've got your graph. Find the slope of the line passing through the points -2, 4, and 3, -5. First, let's go ahead and plot these points. -2, 4, starting at the origin, we go left 2, up 4, plot that point. 3, -5, starting at the origin, we go right 3, down 5. These two pink dots are the only values that were given. To get from one point to the other, and notice this line runs downhill, to get from 4 all the way down to -5, we have to have a vertical change of down or -9 units. To get the values for our horizontal run, or value for our horizontal run, we're going from -2 over to 3, which is a total distance of 5. So we have to go down 9 over 5. That's all we need to know for our slope. That's -9/5. But as a reminder, when you subtract your y values, you're finding the vertical change. To get from 4 to -5, the distance between those two numbers we know is 9 units. -5 minus 4 is the distance between -5 and 4. Remember, subtract finds the distance between two numbers. And then subtracting our x values in the same order, that's 3 minus -2. The distance between 3 and -2 is 5 units for an overall slope value of -9/5.